All right. Hello, physical science. Guys, today we're going to do what's called the blue bottle reaction. And I'll use this as a phenomena to talk about chemical reactions as well as acid and base reactions. Um, and we'll kind of walk you through it. First, I'll go ahead and we'll go through and make the reaction or create the chemical reaction. And then after that, we'll demonstrate it and talk about it. And then I'll talk a little bit about, I guess, some of the dangers involved in these chemicals and how to dispose of it. This is a fairly complex reaction in the way it works out. Um, However, it only involves three different chemicals. Let's see if I can get this to show up on camera. Here is the organic chemistry version of this reaction. What we're going to be doing is basically moving hydrogen around and attaching hydrogen to oxygen or attaching it to different parts of methylene blue, which is the chemical we're going to use that changes color. And it changes color due to this redox reaction. So let's start with our first chemical. The first compound we're going to use is just dextrose or corn sugar. And let's go and tear that off at 0. We're going to need a little bit more corn sugar than we're going to use potassium hydroxide. So we're going to start off with about 8 grams of corn sugar. This will look by volume like a lot more dextrose than we're going to have for the other compound, and that's actually due to density. It's not a very dense compound. It's pretty light and fluffy. So we're going to put a lot in there before we get to about 8 grams. There we go. Okay, went a little bit over, so that's going to be 10 grams of dextrose. Now this is the sugar. In the reaction, this is the species that is going to allow us to go from blue back to colorless. So this is what turns methylene blue into a colorless liquid. So let's set that aside. Now this next chemical that we're going to use, this is the dangerous one, and this is why I'm wearing gloves. So we're going to be using lye. And lye is an extremely strong base. So we've talked about acids and bases. And this one's not an acid, this is the opposite. So this is a base, but this is a very strong base. I'm going to be wearing gloves to protect my skin. This is a chemical we use to make soap because it's used for dissolving organic compounds. And because it's so good at dissolving organic compounds, we also sell it and use it as drain opener, right? Because it dissolves hair and gunk that's left in your drains. So for this one, tear that off. For this one, we're only going to use about 5 grams of this compound. It's going to start in the form of a salt. Right? We talked about what salts are before. And this salt, formed between a metal and a nonmetal, is going to disassociate or fall apart in water and form ions. And then those ions are going to fly around and change the state of some of these other compounds, and that's what's going to cause the color change. So this is the base that's going to drive the chemical reaction. So now we have about 5 grams of our base. And then we're going to use, so we have sodium hydroxide and dextrose, and then now we need just some water, right? We need some water to create a solution. I can turn that off. And we're going to do about 300 milliliters of water, or about 1/3 of a liter. There we go. And what the water is going to do in this is, we've talked about how with acids you form hydronium ions. Water is kind of the vehicle that allows you to transport these hydrogen ions in solution. So it's what allows kind of acids and bases to really do their work. So there's our water. Here's our mixing vessel. And we're going to use, let's start off by pouring the water in our reaction vessel. This is called a round bottom flask or a boiling flask. These flasks are really good. The shape allows you to kind of mix without getting too much splash, right? Because then the splash can be contained down in there. So that'll be the nice thing about that. And then what we're going to add to that is our third chemical that is not water, and that's going to be something called methylene blue. This stuff is used to clean aquariums because it's antibacterial properties, but it's also a good indicator, meaning it changes color depending on acid and base composition. And so this chemical is going to start off giving us a really beautiful blue, but after I mix it with the other chemicals, it's going to go back to clear. So we're going to do just 4 drops of methylene blue into our solution. And now let's go ahead and add our base, our sodium hydroxide. There you go. Now, this is a good chemistry technique. So you guys notice how I have powder still in the bottom. That's because there's some moisture down there. Something you can do, rather than trying to scrape it in there, is you can just take your solution, pour it in here, right, let it dissolve that powder that was stuck down the bottom. Give it a little bit of a spin, and then now pour that in there. Let's do one more. These are called washes. We're going to do one more wash. And then there now. We got the rest of it out. All right, let's do the same thing with our dextrose. Not much dextrose left behind, but we'll do the same thing. We'll do another wash just to clean this one out. And this also serves the purpose of helping us mix our solution while we're doing it. Give it a little bit of a swirl. All right. So now we have 3 different chemical compounds in here in solution. We have methylene blue. In its oxidized form, so when methylene blue is near oxygen, it turns blue. We're going to use the dextrose to take away the oxygen basically and turn it colorless. And that is going to become a colorless liquid in about a minute or 2. Then the other chemicals that we have in here, we have the base. So we have the sodium hydroxide and dextrose or sugar. I'm going to make a little cap because I couldn't find my caps that I usually use, my stoppers. So we're going to use aluminum foil to make a cap to go over the top. Alright, and now as I let that sit there, I can already see it beginning to change color. Hopefully you guys can as well. Let's go ahead and zoom in. And you guys can see the top layer is still a little bit more blue, the bottom layer is turning colorless, and we're losing that color now as the dextrose is absorbing the kind of free oxygen that change the reaction into blue. But then, and this is my favorite part about this reaction, right? So we started blue, now we're at colorless. I'm going to make it a blue color change again, or cause another blue color change by shaking it up and putting oxygen back into the reaction. So we'll do that redox reaction. So you guys should be able to see right now, pretty clear, not much of a sign of a color change. Some of you guys can see a little bit of blue as I even shook it there, and there is a blue ring around the outside of the vessel. Back there. Now watch when I shake it as we add oxygen back into the solution, and now we're back to a beautiful blue color. And within a couple of seconds, that oxygen is then reabsorbed by the dextrose. We get a transfer, we get an acid-base reaction, we get a transfer of hydrogen ions, and the solution goes back to clear. Let's do it one more time. So from clear to blue, absorbing the oxygen that is in the container into the solution. The more I shake it, the more blue it'll get. And now, as the oxygen is reabsorbed by the dextrose and leaves the solution, we'll go back to a clear state. So this is why the methylene blue was blue when I pulled it out of the bottle. Obviously, right, there's oxygen in the atmosphere. So methylene blue is usually blue. But in the presence of this base and the sugar, we can take methylene blue from being blue and turn it into colorless by doing that redox reaction. And there it goes, back to clear. Let's bring up the camera one more time. All right, thank you guys very much. I'll see you in class, and we will talk about this later.